Hello friends, today we start with the new chapter. The name of the chapter is linked list. Now linked list, stack, queue. These are all data structures. Means what? These are all used to store the content, the data that we want to store in the memory, so that whenever we want to access that data, we can access from the memory. We can store maximum amount of data in the memory. We can perform different operations that are contained, the different operations on the data which are in the memory. That are all purposes of using different data structure. In the previous two units also, we are focusing on stack, we are focusing on ADT, we are focusing on queue, different types of queue, how they are storing the data, how they are managing the vacant spaces that are created inside the linear array, in the circular array, in the double-ended queue, etc. In such a manner, we are dealing with the different data structure, and we are understand what are the different ways to store the content inside the memory. Now in the today's lecture also, in this today's unit also, we are focusing on storage of a data, storing the data. We are focusing on again insertion, deletion of a data, as we want to access the data whenever it is useful, or whenever we want to access the data. We just want to access it. Whenever we want to delete the data, use that particular space for another element, we can perform all the manipulations by using the programming, by using the base of algorithm. We can perform all these manipulations. Now see, we are performing the manipulations on thousands of data, not on a 1, 2, 3, 4. That's why it is necessary to study that we are not performing the manipulations on 2 to 3 or 4 elements or 10 elements. Basically, to understand the concept, we are considering 10 elements, 5 elements, 11 elements, 20 elements. But practically, whenever you are performing the coding by considering the base for a data structure in a company or in somewhere else, you are performing the coding on large amount of data. So in that case, our concept should be clear that in what way or at what time we have to use tag, at what time we have to use queue, at what time we have to use linked list, or different algorithms that are associated with the data structure. So this is our way to understand the techniques. This is our way to clear the concept so that in the future we can practically implement that. Now at this stage, our focus is on understanding the algorithms, and before understanding the algorithm, understand the concept. So to understand the concept very easily, you can refer my videos. You can very easily understand the concepts of each and every subtopic that I include in this data structure series, and then try to implement the algorithm based on that concepts, and then try to focus on programming, because only theoretically understanding the concept is not sufficient. We have to develop the algorithm and we have to perform the coding until and unless we can't get the best result, or we can't get the complete understanding of the subject. So this is all about understanding the concept, focusing on an algorithm. Now in this case also we are storing the data. We are deleting the data. Now in this case, one more new thing that we just have to study that. See, in the stack and queue, we are inserting the data from rear end, then we are inserting the data from both the ends as we are having the facility. Double-ended queue gives the facility, so we are inserting the data. But if you want to insert the data in the middle, or we can say whenever we want, in at what position we want. So in that case, what we are doing or what type of techniques we have to insert the data in the middle of the queue, or in the middle of the two, what we can say, two numbers or two elements. So we are using the pointers when we are pointing that data. But to insert the data in the middle, it is a very difficult task, because as far we are not studied or we not think in that manner. So now it is the start that we are thinking in that manner also, that if we want to insert the data in the middle or at position we want, so we can perform it with the help of linked list. So now focusing on the definition of linked list, that is, what is linked list? A linked list, in a simple term, is a linear collection of data elements. In a similar manner, we are also focusing on the linear collection, and these data elements are called nodes. Now here we are creating the nodes. We are not only storing element, but we are storing something else with the element. Means we are storing the address of that element and that element itself. Combination of these two is known as node. So linked list is a data structure which in turn can be used to implement other data structures. Thus, it acts as a building block to implement a data structure. Means we are using a linked list as a base, as a foundation to implement a different data structure based on that foundation. Now the foundation is what? Stack, queue, and their variations. So this is our base. So before going to linked list, it is necessary to understand what is stack and what is queue. So and then only we can construct the building for the data structure by using the concept of linked list. So this is the definition of a linked list. In a linked list, first of all, we are creating a node. That node is consist of not only the element but the address of the next element or address of the element. Just remember at this position, and we are constructing the building by considering the foundation of stack and queue. Okay. Now, as you observe the figure, figure 6.1. In this figure, this is the first form of simple linked list. In this simple linked list, we are creating total 7 nodes. Okay, so one is the data field, and second is the pointer, which are pointing to the next node. Okay, so here we can see a linked list in which every node contains 2 parts. First one is the integer value, that is an element, and next is the pointer, which are pointing to the next node. Now in the left part we are containing the data. So it is including simple data type. So it may be an array or a structure. And in the right part of the node contains a pointer to the next node. Okay, the last node, okay, with the element 7 will have no next node connected to it. So it will store a special value called a null value. It stores a special value called a null value. The null pointer always represented as x. Okay. So a linked list contains a pointer variable, that is start, as you shown in the figure, that stores the address of the first node in the list. See, I am repeating again that linked list contains a pointer variable start that stores the address of the first node that stores the address of first node in the list. Star stores the address of first node, that is node 1 with the element 1. We can traverse the entire list using start, which contains the address of first node. The next part of the first node in turn stores the address of its succeeding node. Means start contains the address of first node. Now here, this is the first node. The address of this first node, it is in the start. Okay. Now the address of this, that is second node, it is there in the first node. The address of third node, right? Third node is there in the second node. Because of that, they are pointing each other. Because of that, they are pointing each other. Understand? And it starts from where? It starts from this start, because this start stored the address of first node. So this is all about a simple linked list. This is a explanation of figure 6.1. Understand? For you, I am again repeating the simply linked list. Okay, just again understand. This is a form of a linked list, which is very simple, which is a starting point. Here, what is that? Here the start is there. Star stores the address of first node. So here, for understanding, I am writing 1. Now it is the time of 1. 1 stores the address of second node. It is pointing. Second knows the address of third. Right? In similar manner, they are storing the address and they are pointing to each other. Last showing as a null. Okay, in this manner, all the data is connected with each other. We are storing the data and we are pointing the different elements. Here we are focusing on only 6 to 7 elements, but practically we can take large amount of data by pointing their address. So here, just think that if we want to insert a new element, it is quite simple, as we are considering different data structure that we studied previously. Okay, now this is the explanation of previous figure. Now next is implementation of linked list. How we implement the linked list, right? So this is one figure 6.2. Now what is the name of the figure? That start pointing to the first element of a linked list in the memory, as we know that we are always starts from first node, and the whatever the data of a first node or the address of the first node is always stored in the star, always stored here, star. Okay, and then journey starts to point other element and to access the data or delete the data, or whatever perform whatever the operations that we want to perform, we can perform that. But starting कहाँ से होती है? तो starting start से ही होती है. So let us see how a linked list is maintained in the memory. Now this is a complete linked list. Now we have to understand that how it is maintained. How it is maintained means how it is storing the data sufficiently. In order to form a linked list, we need a structure called a node which has two fields. We know that, which has two fields. Now what are the two fields? These are two fields, data and next. Right? Data and next, two fields. Data will be stores the information part, and the next will store the address of the next node. Next will store address of the next node in the sequence. Now, to understand this concept, again observe the figure, and I will explain you the complete figure. In the figure, now see here, simply just apply your logic that we starts from 1. Okay, so here in start what we are writing? 1. Means this 1, this starts storing the address of 1. Because of that we are pointing to the data of 1 and next of 1. Now in the next there is a 4. 4 means we are directly shifting to 4. Right? And we are storing the data in that particular location, 4th location. The data is E, and again we are pointing to 7. Right? And again we are moved to 7. Right? Again we are storing data L, and again we are pointing to 8. Right? In the similar manner we are doing the procedure. Okay, understand? This is a data field. This is your data field. This is a next, and next will pointing to the next memory location, and in that we are storing the data. Now line by line understand the explanation of the figure. Now in this figure we can see that variable start is used to store the address of the first node. Right? Here in this example start is equal to 1. Right? Here in this example start is equal to 1. So the first data is stored at 1, which is H. The data is H. Right? The corresponding next stores the address of next node, that is 4. So we will look at the address 4 to fetch the next data item. Like we already discussed that 4, it is the location of next element, that is E. So we are storing E in the 4th location. We are storing E in the 4th location, because we already mentioned that in the first node itself that whatever the element is coming after H, we are storing in the 4th location. In the similar manner, whatever the data which is coming next to E, that is to be stored in the 7th location, because we are already providing the locations by using the pointer. The second data element obtained from address 4 is E. Now from the location we got E, right? We repeat this procedure until reach a position where the next entry contains -1 or null. So here we are following the same procedure till we are getting the null. Okay, so in the last, in the at the 10th position, we are storing some data, that is 0, and in the next we got the -1. So in that case, it is the sign that we have to stop pointing the next node because it's showing the null value. Okay, so this is simple form to understand the linked list and linked list in the memory, how it perform the operations, or what we can say, how it linked to different elements to storing the data in the next memory location. Okay, so this is a simple form of a linked list. Now here it is a explanation of the previous figure that we already explained. Now we are focusing on next topic, that is linked list versus arrays. Now in the previous topics, or in the previous two units, that is introduction to data structure, and the second unit is stack and queue. In the both unit, in the previous chapters, we're dealing with the arrays. To understand the concept of stack, queue in a very systematic manner, we are using the concept of linear array, and with the help of that we can systematically study also what is stack and what is queue. Now in this slide, we just have to understand that what is linked list and what is arrays, right? So we start. Now this is important for understanding the concepts also. This is important for exam point of view also, that is what is linked list versus arrays. And this is important for not creating the confusion between stack, queue and linked list. Okay, so this is the important factor from exam point of view also, that is what is linked list versus arrays. Okay, so this part is important, so we can make it as a star, double star. So we start, that is both arrays and linked list are linear collection of data elements. We know that. Okay, these are both linear collection of data elements, but unlike an arrays, a linked list does not store its nodes in consecutive memory location. Now what is this? See here, for understanding the concept of stack, for understanding the concept of queue, we are taking consecutive memory location. As we discussed that, we are considering linear array starts from the 0th location, end with the 9th location. So 0th location is front, 9th location is rear. We are inserting the data from rear, and then we are performing different type of manipulation to inserting the data, for deleting the data. Right, but unlike the arrays, linked lists are not storing each data in a successive, or we can say in a linear fashion, or in a consecutive fashion, or we can say one by one. Okay, so this is the first difference between linked list and arrays. Another point of difference in array and linked list is that linked list does not allow random access of data. Linked list does not allow the random access of data. See, we are not randomly access the data, we are using a node. In that we are using a data elements, and we are using the pointers. With that, with the help of the pointers, we can pointing to the different types of nodes, and from that particular address only we are fetching the data. So here we are not in a position to access any random data in the case of linked list, because we are having the pointers, we are using the pointers. What is the functionality of pointers? Pointers can point to such a type of address so that we can fetch the contents at that particular address. For the first time in a C language, we are studying a very wonderful concept of pointer, which is not storing the data, but it stores the address of that particular data which we want to access. So here clearly we are using the pointer. There is no chance of accessing a random data. Understand? Now next is nodes in the linked list can be accessed only in a sequential manner. Means see, as you see in the previous figure of singly linked list, it is a simple representation that we are accessing the node one by one. We are fetching the data as nodes gives us a direction that access the content from fourth location we are access the content from seventh location we are accessing. So this is we are doing in a, what we can say, in the sequential manner. But like an array, insertion and deletion can be done at any point in the list in a constant time. Okay, but we are performing insertion and deletion at any point in the case of stack and queues. So this is second, what we can say, second difference. Another advantage of a linked list over an array. So this data, you can consider it as an advantage and disadvantage, write a short note on this and that, or you can consider as a difference. Okay, so in a three ways you can write the answer. If they are asking write a short note on arrays, sometimes write a short note on linked list. So we can, in a short note we can add anything. It is a, in the short note you can add difference point, you can add advantages, you can add limitations, you can add any figure. So we are very what we can say scope to add the information. But if it is a specific that gives the difference or gives the only advantage or gives the disadvantages, then it is the specific answer. It should be expect that you should write a specific answer in that cases. Another advantage of linked list over an array is that we can add any number of elements in the list. Now there is no limitations to add the numbers of elements in the list. So this is not possible in the case of array because array is having some limitations to store the data of 100 elements at a time. Beyond that we can't go, but if you want to go beyond that you can use linked list. Because to study stack and queue we are using the linear arrays only, so there is a limitations of 100 elements. But as we are using here linked list, we go beyond that to store the data inside the data structure. So this is all about the linked list versus arrays. Okay, so first difference is it is the linear collection and it does not stores the data in a consecutive memory location. Second is it is not for the random access of a data. Third is we are accessing the node in a sequential manner. And fourth one is there is no limitations of element. Okay, so these are all about linked list versus arrays. Okay, please remember all the concepts so that while you are implementing that you don't have any type of a confusion.